Hello everybody, my name is Jasmine Brown, and in this video I'm going to be discussing the DMRB's CD357 bridge expansion joints standard. As usual, I like to break it down. So CD means Civil Engineering Design, that's what the CD stands for, and the 357 is just a number that helps you find the document. The aim of this video is just so you can start identifying these different expansion joints yourself when you start reviewing expansion joints on bridges. I'm going to go straight to Appendix A because there's no point in me talking about this document without you knowing what the actual bridge expansion joints are, and I'm going to show you Table A.1. So this shows you the families of expansion joints that this document talks about. So I'm going to take it back a bit and first talk about what ETAG is. Basically, the names of the joints came from this document. The ETAG number 32. It's a European standard from the European Organization for Technical Approvals. And ETAG basically just stands for European Technical Approval Guideline. And then it's number 32. Okay, but this isn't a standard that I'm looking at the moment. I'm going to be talking about CD357. These are the new names on the left-hand side using the ETAG 032 instead of the old way that we used to name the expansion joints. Though when you do talk to contractors or some people within the industry, they still refer to expansion joints as type 1 to 6. We use joints part 2, buried expansion joints, all the way down to part 8, modular expansion joints. Don't get caught up when you talk to people within the industry because they use the names of joints interchangeably. Anyway, I could talk at you and hope that you can visualize it, but I'd rather show you some pictures. I found this website from the Bridge Joint Association. I'm not sponsored, although I wish I was. It shows all of the joints, well, most of the joints. I believe part 8 doesn't have a picture, but I'm going to take you through one by one what all of the joints that CD357 refers to. The aim of this video is just so you can start identifying these different expansion joints yourself when you start reviewing expansion joints on bridges. So the buried expansion joint, I think the descriptions are great. I'll link this website in the caption of this video so you can click on it and go and review it yourself. But it's an in-situ joint consisting of an elastomeric pad or flashing placed across the expansion gap to support the surfacing, which is then laid continuously over the joint. Movement range is plus or minus 5 millimeters. Typically, you won't see the buried joint on a road. You'll only notice that it's there because there's a crack inducer on the road. Here's another good one. So you'll see a surface sealant, which will signify that there's a buried joint there. And then there's part 3, flexible plug joint. An in situ joint consisting of a band of specially formulated binder plus aggregate, typically 500 millimeters wide and 100 millimeters deep, running across the road above the expansion gap. They accommodate movement of plus or minus 20 millimeters. And this is what it looks like. This is another good picture. There's flexible material, and then here's your expansion gap. And then it typically looks something similar to this. Okay, don't show it. Okay, so typically it looks something like this. So just imagine this is the surfacing of the road, and then this is the flexible material. It's usually, as it says in the description here, it's 500 millimeters wide and 100 millimeters deep. So part 4, nosing expansion joint. In situ resins or cementitious nosings placed either side of the bridge deck air gap to produce firm edges and protect the surfacing, complete with watertight extruded compression seal or sealant. Here the associated picture. Part 5, matte expansion joint. I won't read the whole thing because I'm sure you can read. Typically they look like something like this in the real world. And then this is a cantilever expansion joint. So these joints are like tooth joints, so they interlock like this, as you can see in this picture. Supported expansion joints, part 7. And these are designed to accommodate large movements with good riding quality. Modular joints are also known as elastomeric and metal runners, and they look like this. You'll see these on bridges quite a lot. Okay, so I'm going to wrap up the video here. Thank you guys so much for watching in this introductory video for junior engineers to start identifying the different types of expansion joints they can find on the network. And I hope to see you guys in my next video. I'm going to do a part 2 on CD357 to discuss the other parts of the document, and we'll go through the general requirements for bridge expansion joints, the selection of joint types, etc. I'm going to break it down. I'm always open to some feedback, and I hope to see you guys in my upcoming videos. Bye now!